Hey guys, welcome to lesson 4.3, where we look at potential problems and pitfalls in experiments and observational studies. So 5 things we're going to look at specifically. The first being looking for causation from observational studies. Remember, we can only ascribe that from experiments. Extending results inappropriately, so getting some sort of result and then generalizing it inappropriately. The Hawthorne effect, the experimenter effect, and using the past source of data to draw some sort of conclusions. So the first one, implying causation from observational studies. The rule for conducting cause and effect relationships can be inferred from randomized experiments, but not from observational studies. That's one of the most important things to take away from chapter 4. Partial fix for researchers, measure possible confounders and account for them in the analysis. Causal conclusion still is not justified from observational studies. Too many other confounding variables could explain the cause and effect relationship. Example, do nightlights cause nearsightedness? A 1999 observational study found that children who slept with a nightlight on before the age of 2 are far more likely to become nearsighted later in adulthood. The claim, headlines, warned parents to turn off nightlights to protect their children's eyes. The confounder, was nearsighted parents. They pass on myopia genes to their children, and seeing poorly in the dark, they are exactly the parents that are most likely to install a nightlight. Follow-up studies found that once parents' vision was accounted for, the nightlight link faded away. So from an observational study, linked to never becomes caused by. So once again, you can only ascribe causation to randomized, well-designed experiments. Problem number 2, extending results inappropriately. Results only extend to the population that the participants represent. Random samples extend readily. Observational studies built on random samples generalize to the sampling population. For example, a sleep medication trial on volunteer college students may generalize to healthy young adults, but extending it to elderly patients with chronic conditions requires judgment that the data won't let you make. So make sure you know what sort of people were part of the experiment, and you can only generalize to the type of group that these people represent. So if the volunteers were college students, you should probably only generalize to groups that are similar to college students. Problem number 3, the Hawthorne effect. So the idea here is that participants respond differently. Participants respond differently, usually better, simply because they know they're part of an experiment and are being studied. So if someone knows they're being studied, or if someone knows they're being watched, they're going to respond differently. The namesake, the effect is named for the Hawthorne factory studies in the 1920s. Worker outputs rose no matter what the researchers changed. Brighter lights, dimmer lights, anything, because the workers knew they were being watched. So they told the workers that they want to measure different things to see if they increase productivity. And shockingly, every single thing that they tried increased productivity, mostly because the workers knew they were being watched. The experimenter effect. Researchers themselves can have bias in several ways. So researchers can be biased in the way they record data, the way they handle groups differently beyond the treatment itself. They can give off subtle cues or tells with the expected response. So one of the ways to account for that is by doing double-blind studies that mitigates the experimenter effect. A classic example of that is the doll rats experiment. They set up 12 experimenters, each received 5 rats that had been taught to run a maze. All the rats were essentially identical. 6 experimenters were told the rats were maze bright, and the other 6 were told the rats were maze dull and shouldn't be expected to do well. So the maze bright rats were judged to be far superior in learning, and the maze dull rats were judged to be much poorer in learning. But they were all identical. So the only difference was the experimenter's expectations. So expectations can have a big effect in how people judge situations. If you're told that someone is smart and hardworking, you might treat them very differently, either consciously or subconsciously, if you're told that they're dumb and lazy. Problem number 5, using the past as source of data. 2 dangers: people recall past events inaccurately. That's a big one. And yesterday's confounders and yesterday's definitions may differ from today's in ways researchers don't think to measure. For example, a study asked retired football players how many concussions they suffered during their careers many decades ago. Memory is unreliable, especially if you've had some concussions, and the diagnostic standards have changed so much that the official concussion in 1985 is not the same as the event today. So not only did the definition of a concussion change, but asking people who have been, hit in the head multiple times to try to recall how many concussions they've had is highly unscientific. So there's not a lot that you can do about that. But basically, if you are drawing conclusion from data from decades ago, that should be a red flag. So quick check. Call center's rep performance improves during the month they know they're being observed, no matter which script they test. So this is the Hawthorne effect. Graders who know which essays came from trained groups score those essays higher. That's the experimenter effect. A survey finds that families who eat dinner together have kids with higher grades. A headline says, family dinners boost grades. So they're saying the dinners cause higher grades. So this would be observational study. So inappropriately drawing conclusions from observational studies. Last one, a sleep app trial conducted on college students, volunteers is marked to retirees. So generalizing results inappropriately. All right, so key terms, rule for concluding cause and effect. Causal relationships can only be inferred from randomized experiments. It's something a theme we've discussed. Hawthorne effect, participants respond differently simply because they know they're being observed. Experimenter effect, bias from the researcher, erroneous recording, unequal treatment of groups, or subtle cues about the desired outcome. So researchers can, again, this is one of the reasons that we might want to blind the researchers. Retrospective data about the past, vulnerable to faulty recall, and the confounders and definitions might have changed over time. So summary, cause and effect can only be concluded from randomized experiments. Results only extend to the population from which they came. Hawthorne effects and experimenter effect are tamed by identically handled controls, double blinding, and automatic recording. Data about the past carry 2 hidden risks: faulty recall and confounders and definitions that might have changed since. So that is our last lesson from chapter 4.